Hi, welcome to Chapter 6. Chapter 6 is going to get into these. It's kind of like the procedures and the modules that we've dealt with in the past, but they're called functions. And functions work a little differently than modules or procedures, in that we can treat them almost like a variable. So you'll see what I mean here once we kind of see some of the different examples. So the very first thing this chapter talks about are things called library functions, or what I like to call built-in functions. So these are functions that the particular IDE you're working, integrated developer environment. It's like Java, Eclipse, I mean some of the different areas we work in. So Java provides a ton of built-in functions, and these are basically brought in automatically, and we can utilize them. So the very first thing it talks about is this one called random. So in a Java or VB or Python or R or Scala, any one of these new languages that are out there, they all have a built-in function called random. What that means is it will basically provide you a random number. You just basically say, I want a number between 1 and 100, and it will go ahead and give you a random number between 1 and 100. So let's just take a look at Raptor, and let's see a built-in function. So right away we're going to notice that we create a number variable. We set it to 0. We just declare it as integer. The next thing we have is we're going to make number equal to this thing called floor. Now what floor does is floor is a converter in Raptor. It will basically convert it into a numeric value, so to speak. But not so much the floor. What we're worried about here is this thing called random. Now what random does is random creates a random number between 0 and 1. So it seems kind of weird that, wow, between 0 and 1. So here's what we have to do. We're going to take random, and so in this case we want a random number between 1 and 10. So to do that, I take random and I multiply it times 9, because that's basically 9 is, because what that's going to create is random is going to create a number between 0 and 1, and when I multiply it times 9, that means basically is going to give us a number between 0 and 9. Well, I want a number between 1 and 10, so to make that 1 and 10, I add 1 to it. So whatever number it gets back, it will have 1 added to it. So if a 0 comes back as a random number, it'll be a 1. If a 9 comes back as a random number, it'll be a 10. Okay? So that's really all that's doing. So there's actually two functions going on here. The floor function, which basically makes it numeric, and then we've got the random number, which basically, and the reason we're doing that floor is because we want to add 1 to it. But so the random is really the function we're looking at. So if we look at this, we're just saying number equal all of this gobbledygook here. It's like, wow, that's kind of magical. And that's what a function, that's the beauty of a function, is I can say I want this variable to be equal to this function, and whatever that function return is put into that variable. So that is the ultimate purpose of a function. So I'm basically saying make this number equal to that, and then I go ahead and put the numbers. So if I run it, I get a 6. Click it again, I get a 9, 2, 7, 8, 5. Okay, so it's just random numbers basically keep coming back. And I'm seeing a pattern. I don't see a 3. Oh, there's a 3. Okay, so I guess there isn't a pattern. My bad. So that is the greatness of a function, is I can say this variable is equal to that function. Now let's continue on before I basically get to that point. I was going to make a point there, but let's just go on from there. Okay, so let's take a look at 6.2, and 6.2 creates a number variable, sets to 0. We have counter set to 1. This is a for loop. We're going to do for loop 1 to 5. So you say while the counter is greater than 5. So if the counter is greater than 5, we're going to basically get out. So remember, the raptors are until loops, basically until they become true. So we say number is equal to random. Now this is going to create a random number between 0 and 99, and we add 1 to it. So it's really a random number between 1 and 100. And so we basically get a random number, we display that number, we add 1 to the counter so we can go through the loop again, and it's just going to basically give us 5 random numbers between 1 and 100. So I run it, there's our random numbers. I run it again, random numbers. Random numbers, random numbers, okay? So it just keeps returning 5 random numbers. So let's take a look at 6.3. Now the difference between, okay, so if we look at this one, I'm saying let's take the number and make it equal to that function. Let's take a look at 6.3. It's going to do it a little differently. It just basically says display that function, and it displays that number. So instead of doing the number equals the function, I just say display the function as output. And we're going to get the same exact results. I run it, there's 5 random numbers, 5 random numbers, 5 random numbers, so on and so forth. Okay? So again, a function is kind of like a variable. I can just display it, I can just make a variable equal to a function, and I get the same exact results. Okay. So in the spotlight, this is Dr. Kumura teaches an introductory statistics class and has asked you to write a program that he can use to simulate the rolling of dice. The program should randomly generate 2 numbers in the range 1 to 6 and display them. In your interview with Dr. Kumura, you learned that he would also like to use a program to simulate several rolls of the dice, one after the other. You decide to write a loop that simulates 1 roll of the dice and then ask the user whether they want to roll another. Okay? As long as the answer is yes, we'll keep rolling. So let's take a look at 6.4. So we declare a variable called again is equal to no, and basically, and then we got our loop. This is basically, I should put a comment in here that this is a while or / until loop. And so now we basically, inside the loop, we say rolling the dice, their values are, and then I'm just saying put, and I'm just calling the function. And notice it's random times 5, because it's 0 to 5 at that point. I'm adding 1 to it, so it's actually 1 to 6 now. Okay? And it says, do you want to roll again, yes or no? I get that answer. If it's not equal y, because remember, I'm saying if it's not equal to y, then we're going to basically loop again. And we're going to keep doing that loop. So notice this is a do until. Okay, this is a do until loop because we're actually doing something first before we actually check the loop down here. Okay. Once we get to y, we basically, if it's not equal to y, if that's true, we basically drop out. Okay. So we run this. And rolling the dice, their values are 2 and 1. So do you want to roll again? I'm going to say yes. We get 2 and 3. Yes. 2 and 4. Yes. 4 and 4. 5 and 3. 5 and 4. 2 and 2. 1 and 4. Okay. And I finally say no, and the program ends. Okay. So we've seen that type of loop before where we use the sentinel. Not a sentinel, but we use the yes, no to basically say, do you want to continue on or not? So we got another in the spotlight. So Dr. Kumura, all happy with the rolling of the dice. He asked, could you write one more program? He would like a program that would use something like 10 coin flips, okay, on a display whether it's heads or tails. Now this is going to be a little different. The random is going to be just a little different here. So let me open up number 5. And here we're just saying floor random times 2. So we're basically doing, and if it's equal to 1, we're going to put heads. If it's not equal to 1, we're going to put tails. Okay? So again, we're basically just grabbing two numbers. If it's equal to 1, you get heads. If it's equal to 0 in this case, it's going to be tails. Okay? So when I say random times 2, I'm just getting a 0 and a 1. That's all I'm getting. Okay? And then I basically add 1 to the counter because this is a for loop. I need to basically put that comment in there. This is a for loop. We're going to do it 5 times and then basically end. So I run it. There's the 10 flip of the coin. I click it again. Notice that they basically change. So they are basically random. And we can do that all day long and get 10 random coin flips. Okay. So random times 2 just gives us two numbers, 0 and 1. And if I say if it's equal to 1, boom. So notice that I actually can put that function directly into a decision structure. I don't even have to basically put it into a variable. I can just utilize that function directly as a variable. Okay. So now writing your own function. So this is what I was going to try to talk about earlier, is Raptor doesn't give us the ability to create our own functions. What I mean by that is where I can say a variable is equal to a function. All we can do are create modules. So this is where it gets kind of gray for us because we kind of see how a function is used and called, but the rest of this chapter, or the rest of this section, is going to pretty much be just utilizing modules and passing data back. So, but the ideal of a function is this: is if we look, I've got the function, and then it's got integer here, and what that means is this function is returning an integer data type. Now a function will always do that. A function will only pass back one variable. Okay? It will only pass back one variable data type. That's it. We can't pass back 2 variables. We can't pass back 3. It only passes back 1. So we always tell in the header what's being passed back. So in this case, this function is passing back an integer. The name of this function is called sum. We are passing an integer called num1, another integer called num2. I declare a variable inside of here called result. Result is equal to num1 and num2 put together, and then notice I have a return statement. Return is basically saying return this result in this integer. So here's what I can do is in my pseudocode here I can say here, line 13, set total equals sum first age comma second age. And notice that since this is a function and that function is returning an integer, it's going to put the result directly into total. Okay? And then we can say display total. Together you are total years old. Now, Raptor, we don't have that ability to create a function. So what we do instead is I have this sum. I do a right click on it. It's basically got the name of the procedure is sum. I've got first age, second age, and notice that the output is result. Okay? So let me try something. I'll be right back. I wanted to try something offline if I could truly make this a function, and no, Raptor will not allow me to do that. So basically, again, this is more or less the previous 2 chapters ago where we were doing modules and procedures. I've got first age set to 0, it's an integer. Second age set to 0, it's an integer. I have total set to 0, and it's integer. And then I say enter your age, get first age, enter your best friend's age, get second age. And notice that I've got sum, first age, second age, and here I've got result. I don't have result in here anywhere. So in a sense, the sum function actually created that variable result as an integer and then passes it back, because up here it says out result. So in a sense, yeah, I've got total equal result, and yeah, that works, and that works okay. I've even tried this. I've even tried going into here and say make that equal to sum, and it will not let me do that. Well, let me try this. Yeah, sum is not a function. So I can't do that since sum is not declared as a function, and we can't declare things as functions. So so really what I have to do is this, is I have to make that equal to result, and then it basically works just fine. So again, this is not so much a function, it's more of a procedure in Raptor, but just kind of bear with Raptor at this point to understand how that works. So we run this, and it says enter your age, enter your friend's age, and it says together you are 109 years old. So it basically went into that sum, got the result, and we got the result back, and I can basically put it in there. So what's kind of nice is I don't have result declared anywhere in here, and I can just utilize it. So kind of in a sense that's like a function, but anyways, just realize we can't write our own functions in Raptor. Remember, in the pseudocode, or actually in the real programs, we always have to have a return statement. We have to say what we are returning as this. Again, this could be a function integer, it could be a function real. So whatever that is, we have to be returning that particular item. So let's take a look at 6.7. And so in this case, we've got get regular price and we got discount. Now really what they wanted to do here is they didn't want to do this call right here. They just wanted to say sale price is equal to regular price minus the discount as we pass those items in. So what it looks like is this: set sale price equal regular price minus discount, and we're passing in the regular price. Okay. So, and again, they're using a global variable up here. Again, we can't use global variables in Raptor. So instead, what we did is we created this discount percentage here. We passed it to that discount procedure and passed in the regular price, and we got the discount amount back. Okay. I see, and I could probably do the same thing here. I could probably take this discount amount and go here to discount and paste it here. And then back here in main, I don't have that discount amount. I just say sale price is equal to regular price minus discount amount. So which is basically what's being passed back right here. So the discount amount was actually declared in the discount function, so to speak, procedure. We're going to call it a function just because that's what we're covering right now, but it really is a procedure in Raptor. So when I run it, I'll make this an easy example, make it $20. And so the regular sale price is 16 since it's 20% off. 20% of 20 is 40. Take 40 or 4. We take 4 off of 20 at 16. Okay. So again, I remove the discount price a discount amount, because that's basically what's being passed back here and basically passed in here. Okay. Talk about IPO charts, input, processing, and output. We basically get regular sell price. The input is none. The processing prompts the user to enter the regular price. The output is the regular price as real. IPO chart for discount is the integer is input. We get the item's regular price. We calculate the discount price by multiplying the regular price by the global constant discount percentage, and then the item's discount is basically passed as real. Okay, so another in the spotlight. Hal owns a business named Make Your Own Music, which sells guitars, drums, banjos, synthesizers, and many other musical instruments. Hal's sales staff works strictly on commission. At the end of each month, each salesperson's commission is calculated by this table. Less than $10,000, they get 10%. $10,000 to $14,999 is 12%. $15,000 to $17,999.99 is 14%. $18,000 to $21,999.99 is 16%, and $22,000 or more is 18%. And so the calculation is pay is equal to sales times commission rate minus advance pay. So let's take a look at program 6.8. Now, down here, they are going to basically set commission rate equals determined commission rate and sales. So that is the function. They're just basically making a function equal to a variable. Again, we don't have that luxury in Raptor, so let's take a look and see how we would do this in Raptor. So I've got my sales set to 0, commission rate set to 0, advance pay set to 0. Since those are real, that should be 0.0, by the way. And then I've got get monthly sales. I pass in monthly sales. Okay. What is get monthly? So get sale. Oh, so it's determined there. So monthly sales is created there and then passed back. Okay. So all we're doing with this is passing back monthly sales. Okay. And then sales is equal to monthly sales. Okay. Then I got get advance pay, and I basically pass in advance. So we don't have advance here. Advance is declared. Ooh, it needs to be declared here. So advanced, my bad. So we declare advanced. Here we basically say what is the advance, enter amount of advance pay, or display 0 if no advance pay was given, and we get the advance pay. Okay. We come back here. We now have advanced, and I can say advance pay is equal to advanced, and then I determine the commission rate, which is sales and rate. The commission rate is equal to rate, so again, this should have been a function, this would have been a function, this would have been a function as well. And then I say pay is equal to sales times commission rate minus advance pay. The pay is, okay, so if they got an advancement and now their pay is less than 0, meaning they got too much of an advancement, we will say the salesperson must reimburse the company. Okay. We could probably put what that pay is if we were to do some type of an equation right here. Okay. So determined commission is this big long string. So I've got my rate set to 0. If the sales are less than 10,000, the rate is 0.1. If they're between 10,000 and 14,999.99, the rate is 12. Between 15 and 17,999.99, it's 0.14. If it's greater than 18 and less than 21, it's 0.6. Else, anything else is 0.18. So what is passed back? The rate. And that's basically what we get when we basically call this guy right here. Notice we don't have a rate up here. We have commission rate. And so there it is. Rate is commission rate. You know, I'm thinking you could basically kind of streamline this a little bit by, instead of passing rate, and we wouldn't even need this guy right here, right? Because we've already got the commission rate determined up here, and so this guy is just calling that with sales and commission rate and basically bringing it back. Okay, so yeah, there's the rate. So the rate's basically created here and then passed back inside of that. So that streamlines it a little bit. We should get the right amount here. So if I click here, well, let's make it the pay is -500. The salesperson must reimburse the company. Okay, so let's run it again. What is commission rate? Oh, it's set to nothing. So what happened there? Maybe I do need rate. So let me go back here, and again, my little experimentation might not be working correctly. So let's run this. So commission rate is, okay, so it worked. It worked fine. Commission rate is 1200 because we were at 14, so it was basically between 10 and 14,999, so it's 0.12, so it's working fine. Okay, so it was working. So let's keep running. So what is the pay? Pay is equal to sales times commission rate minus advance pay. Sales are 12,500 times commission rate. Why is pay 0? Oh, commission rate is 0. Oh, did I have it spelled wrong? Yep, I have it spelled wrong. So let me grab this guy. And plug it in here. And now it should work fine. Pay was 1,500. Okay, so so we could do this. I could run it again and say, okay, now they 12,500, and they got $500 in advance pay. So their pay was 1,000. So we saw it was 1,500 before. Now they only get 1,000 because they have to pay back that advance pay. Okay. So as you can see there, instead of doing this sales equal monthly sales, I could just basically do this. Whoop, and just make that sales. I don't even need that. Okay. And I can do the same thing here. I can actually make that advanced pay, or no, just make that advanced and get rid of this advanced pay, and down here just make that advanced. So I just got, do I need commission rate just at, set here, or is it basically determined over here? Well, it's got rate. Okay, so we need it there. Advanced pay we don't need. I could just get rid of that guy and basically call it rate. There we go. Okay, so we basically we got our sales. We have to get our sales because we have to determine that over there. So we basically have that. We have our advanced, which is basically created inside of this call statement. We have rate, which is created inside of here as well. We have advanced. Okay, so we're basically using the commission. Whoop, I need to change that to rate. Okay, so now this should work. We got less variables here. Again, I'm trying to make this more streamlined for get it as close to a function as possible. Yep, still works fine. Okay, I like that a lot better. And that needs to be 0.0. Okay. So they kind of break it out, show all the different functions, and again, here's their nested if statements to basically determine the commission rate. We can return a string, so here's a function string get name. So we can actually ask the user get a name. If we're, again, this is if we have a function that we can create. So we create a function. And we have string and the function saying that I'm going to return a string. And so now I declare a string called name. I say to enter your name. I input that name and then I return the name. So I can actually say this function is equal to, or this variable is equal to get name. And then 2 parentheses. I can also do the same thing with Booleans. Okay, I can actually then return a Boolean and put that into a Boolean field. Yeah, so here's another one. Is even. Now this is a really cool one to use because the name of the function can be used directly in an if statement. So I'm returning a Boolean, it's called is even, and I'm passing in an integer number. So if we come down here, it says if is even number. Pretty cool. So this whole thing is going to be either true or false since it's a function. And so I just got to say if is even. So that's another great thing about functions is if you're going to use them in an if statement, and it's a Boolean, you can actually give that function name the verbiage of what you would use in an if statement. In this case, if is even, if is true, if is a large number, meaning if it's greater than, larger than 100, okay? If is a 3-digit number, if is a 4-digit number. So those are the function names you could use within an if statement so that it's really easy to basically utilize since it is a function. Okay, so no more. So they call them library functions. I like to call them built-in functions. These are built into Raptor. These are built into different things. And Raptor does have what's called the square root function. Okay, so if we look at program 6 and 9, here we have a number. It's an integer. We have a square root. which is a real. We say get the number, we put that in the number, and then I say square root is equal to SQRT number. So this is a built-in function. So notice the function, I can say a variable is equal to that function because it's going to return a numeric variable. The square root of that number is square root. So I run it. If I type in, let's say 25, the square root of that number is 5. If I run it again and I say 8, the square root of 8 is 2.8284. Now, this is another built-in function we can use. Is I could actually put another function call right here, and if I type SET, it automatically brings up some built-in functions. The one I'm looking for is this one called set precision. Now, set precision will allow us to control how many decimal places we want. If I put in, let's say, 1 here, from this call forward, from that call forward, all numbers will have 1 decimal place. Even if I've tried to set it as an integer, it will still have 1 decimal place. Okay, so just be aware of that. So if I run this now, I type in an 8, it comes back as 2.8, and it will round. It will round properly. So in this particular case, I'd probably want that to be more of a 2. Now, here's kind of a strange thing about the set precision. If I set it to 1 or 0, it will always return 1 decimal place. If you want no decimal places, you would have to use a -1. So let me first run this with the 2 decimal place to show you what it looks like. There's 8, and there's 2.83. Notice it was 2.828. Well, it rounded, so it's 2 decimal places, it's 2.83. So if I then change this to a -1, well, first let me change it to 0, show you what 0 does. Again, 2.8. So basically a 1 or 0 always brings back 1 decimal place. But if I come in here and change that to a -1, and now run it, it rounds to, oh, it didn't work at all. Huh. I thought -1 is what saved the day. Okay, well, we'll just leave it 2, and I'll have to figure that out and put it up there. And I could have sworn I did the other day. It worked fine. Okay, anyways, so set precision allows us to set the number of decimal places. Let's look at 10. So 10, here we set a variable A, B, and C, and we enter this length of side A, we get A. We enter the side of length B, we get B, and then we basically say, so we're trying to figure out the hypotenuse of a rectangle or a parallelogram. So we basically say C is equal to the square root of A squared B squared. Add it together. And then it says the length of the hypotenuse is C. Okay, so if I run this and I have a length of side A is 12 and side B is 14, it basically says the hypotenuse, the length of the hypotenuse is 18.4391. Okay. Now, if I needed to reduce that number of decimal places, remember I could go ahead and put that set precision in here. Again, these need to be 0.0 or 0.0 to show that they are truly real. It really doesn't matter, but programmatically, I want you to kind of get in that mindset of, oh, if it's a real, make sure that we have a decimal place. Okay. The POW function, I don't know if the POW function is, but it basically allows you to raise to a power. For example, if I wanted to have 4 squared, I could say POW 4 comma 2. That means 4 times 4 twice. Okay, so 4 times 4. If it was 4 comma 3, that would be 4 times 4 times 4, so on and so forth. But we can do that in Raptor via the what we call the caret symbol, which is Shift 6 on your keyboard, and that will give us the caret symbol that says raise a multiply a times itself twice. If that was a caret symbol 3, that would be a times a times a. Okay. Some other built-in functions. Again, these are not all available in Raptor, but most all languages have these. ABS, which gives you the absolute value. COS, which is cosine. Round. Sin, which is a sin of the argument. These are all basically algebraic and trigonomic type of. Tan brings back the tangent of a number. We also have built-in functions to integer. It will convert it to an integer, or it will convert it to a real. So if I have an integer, I need to convert it to a real before I utilize it. I can use those functions if they're available. And that's basically what program 11 is doing right here. Is we've got ounces per person equal to 8. How many ounces lemonade do you have? Input ounces. Set number of people equal ounces divided by ounces per person. And what they're saying is the ounces is the number of ounces lemonade will be available. Now it's going to work for us because we really don't have a way to set the data type in Raptor, so it's going to work just fine. But what they're saying here is that line 17 attempts to calculate the number of people who can be served, but there is a problem. Number of people is an integer, and that's expressed as, so here's what it's saying is, number of people is an integer. Anytime you do division, most of the time it's going to bring back a decimal place. So if this was a real program, let's say Java or Python, this number of people was set as an integer, it's going to truncate off that decimal place. So that's where the error's coming into play here. So we can look at it, but it's going to work just fine for us. Okay, so number of people is set to an integer, ounces is set to real, this is set to a constant, and when I basically run this, okay, number of people, so let's say I run this, and I basically say I have 36 ounces, you can serve 4.5 people. Well, that's not correct. I don't want 4.5 people. You know, how do I serve a half a person? So again, in a real world situation, that would have given us an error. So we take at 412, and so what are they trying to do here? So at first you might decide to change it to a number of people to a variable to real, but that would fix the error, but it would also not make sense to hold that number of people. So what we need, so what they do here is set number of people to or equal to integer ounces divided by ounces per person. Okay, so that's going to basically convert that into a, okay, so how do we set to, yeah, there's just really no way to just truncate. Well, I think programmatically we could go into Raptor and really create a really crazy, wow, yeah, we could create a crazy module that would basically strip off everything from the period on, but just realize we don't have that option. So really that's what this program's trying to do, is trying to basically say it's not 4.5 people, it's actually 4 people. Okay, we do have a length function, so we do have the option of and we don't have, So there is a 2 upper and 2 lower that I have written myself and actually have it out there that we can utilize. I will basically have it out there in Moodle rooms. But yeah, it basically is a module that will basically convert a lowercase letter to an uppercase letter. So yeah. So really, if we had a built-in function 2 upper and 2 lower, it would basically, oh no, I think, you know what? I think there may be. Yeah, there is a way to convert, and if I remember, okay, so let me see if I can, yeah, let me go get it. Okay, so let me open up Raptor, and let me open up a new one, and I believe I'm going to create a procedure called 2 upper, and I'm going to, okay, see if I can paste in here. Okay, yep, so here's how it works. We've got 2 upper is the name of this, and I'm going to pass, I need to pass in a string. So let me go in here. So I'm going to pass in this thing just called a string. You don't have to call it that. You can call it anything you want. And that's input. I think we're going to pass it in and out. Right. So we got in string coming in. And what it does is it gets this, the length. So here is a built-in function that's built into Raptor is called length of, and we basically say string. So this is now a numeric value. We should have done this, by the way. And so we've got size. Now once we get the size of this string, we're going to set our position to 1. So we're basically going to try to start on the very first character. Now I go into a loop. So if position is greater than size, we're done. Okay? If we're not, we're going to say a string position. So basically we're going to say grab this variable, this string variable, and grab whatever position it is. And if it's an A and string position, so if it's greater than or equal to A, and less than or equal to z, lowercase z, if that's true, we are going to say a string position is equal to a capital letter A plus a string position minus A. Okay, so what we're doing here is, it seems kind of weird. I'll try to leave a video link on how this person explains a lot better. But we're looking at the ASCII numeric values. And we take one and subtract the other, and it basically will give us, so basically in a sense it takes those two and subtracts those numeric values and then basically returns the uppercase numeric value for that guy. And so then, so that's basically as a conversion process right there. And then we add 1 to the position to go back to the next position of the name, so on and so forth. So I could basically then do this. So I create a variable, string variable called name. I pass that variable to the 2 upper procedure, and then I display. So remember, I'm passing it in and passing it back. So let's see if it works. So I basically run this. Well, it helps if I get the name. So I got to input the name first. Okay. Okay, now let's see if this works. So I run it, it comes up, enter name, I'm going to type in a name, and it displays mark all uppercase. Okay, there's also a to lower we can create as well. So again, I will try to leave a video link in Moodle Room so that we'll explain this a lot better. Again, it's taking these ASCII values and subtracting them so that it basically gets to the correct value. Or I should say it gets to the uppercase value of that letter. Because realize, in ASCII there's 256 different values. There's 26 values for all the uppercase letters and another 26 values for the lowercase letters. Okay, so this is great. You can actually just take this upper, copy this code, and then put it into a procedure in your document, and then or into your program, and then basically just call it. So it's nice you don't need. So to copy this, you would just basically click up here and drag all the way down to the bottom, and basically do a edit copy, and then open up your new program and do an edit paste, and then basically paste it in, or create a new procedure called to upper, and then just paste it in. Okay, so that is that particular one. So there is a substring function. Let's take a look at that. Okay, so let's just so 513, I'm sorry, I'm in the wrong program. I need to be in 6. So 613, how to get a particular, well, in this case, here's what we're going to do, is I'm going to type in a string, and I want to know how many uppercase T's are there. Okay, so I create a variable called str, it's a string data type. I create an integer called numTs, and then I say enter a string, and I get str. Okay, the length of, so again, this is the length of that string. If I typed in 10 characters, I'm going to get back the number 10. And we're going to put that into the len variable. I set this index equal to 1, and then I loop through. And so what I'm doing here is, if the index is greater than length, then we're done, we drop out of the loop. But if it's not, we say if str index is equal to, now here's kind of a rule that we have to follow. When we are dealing with single characters, not numbers, not anything, but characters, okay, we put single quotes around them. Every other type of string, we put double quotes, okay? But when we are dealing with a single character, we use single quotes. So I'm saying if str index is equal to single quote, uppercase T, single quote, again, what are we doing? I'm looking at the number at that, or I'm looking at the character at that position in this string. If it's true, I'm going to add 1 to numTs, and then I'm going to add 1 to my index and come back around and go to the next position and check to see if it's a uppercase T. And when I get done, it's going to tell me how many uppercase T's were there. So if I run this and I type in hello world, there's no uppercase T's in there. It comes and says that string contains 0 instances of the letter T. So if I run this again, I type in the program is 3. There should be 2 capital letter T's in there, and it came back and said there are 2 instances of the capital letter T. So what this is doing, this str square bracket index is basically looking at the position of the string, at that position. So at hello world, H is 1, E is 2, L, so 3 and 4, O is 5, space, that space is number 6, and then 7, so on and so forth. Okay. So that's kind of how we do that. The way they would do it here in pseudocode is they would use the substring function. They would say the str.counter, counter. So at that position to that position, that's how that would work. So they're saying, so the substring function says take this string and start at this position and end this position. Well, since we're using a counter, it says, let's say it's a 2. Start at position 2 and any position 2, bring that back. That's basically what that's doing. Contains is another function. We can actually say, use a contains, if I believe this is available in a lot of languages, where I can use a function called contains, and it will actually say, and I could put a capital letter T in there, and it goes out there and basically does all that by itself. Okay. We have a string to integer and string to real functions. These are kind of dangerous because it actually takes, because realize a numeric 1 is different than a string number 1. One's a string, one's a numeric value. They're completely different. They may look the same, but they are completely different as data types. There are some built-in functions, some language where we convert it from a string to an integer and a string to real. Again, you got to be very, very careful with those. We also have what's called an is integer function, an is real function, and we could basically utilize those as well. Again, a lot of these are not available to us in Raptor, but just realize that as we get into as we progress into a programming language, these different types of things will basically be available to us. Okay, so that's it for chapter 6. If you have any questions, please contact me. I'd be more than happy to help. We'll see you next time, chapter 7.